Hey guys, welcome back. So today we're going to continue on with our properties of integers review, and I've decided to kind of take a different approach and start doing more example problems because I found that just covering all of the material in the book might be kind of redundant because you guys are probably already doing that on your own. So I'm going to try to walk through some of these problems and give you solutions, and hopefully that's helpful. If you do have any feedback, please feel free to email me. But anyways, let's go ahead and get started. So our first problem says, for which of the following values of n is 100 plus n all over n not an integer? So what you want to think of here, first of all, is what is an integer? So that's really essentially what this problem is asking, and it's always helpful to think, what is this problem asking me? Why is it asking it? So an integer, if you remember, is a whole number, so it cannot have a decimal. So whole number, no decimal. Okay, so now that we know that, let's think about what we're given and what we can do with it. So we're given this 100 plus n over n, and we want to know for which of these values over here, 1, 2, 3, 4, and 5, this is not an integer. That's another thing you really need to pay attention to. Anytime there's the word not, really pay attention to that. So when I did this problem, the easiest way for me to think about this was to think about this as 100 over n plus n over n. Okay, so all I did here was I just broke down this fraction. So that's another thing the test is kind of seeing if you know, is if you're up to date with your fractions. Because if you remember, so I'll go ahead and review fractions here. Whenever you add fractions, if you have a common denominator, you just add straight across. So here, we do have a common denominator of n, so we add the numerator, and then you keep the denominator the same. So another example, here I'll write this in purple over here, is if I have 2 over 4 plus 1 over 4, if you remember, you add the numerator, so that's 3, and you leave the denominator the same. So going back to our original problem, so I was right here in this step. Let's go ahead and over here. Okay, so now what is n over n? This could be another property of integers problem. Any number over itself is just 1. So this is essentially 100 over n plus 1. So 1 is an integer, and anytime you add an integer to an integer, the answer is going to be an integer. So now all we really need to do is plug in these values and figure out when this part is not going to be an integer. So 100 over 1, is that an integer? Yes. 100 over 2, is that an integer? Yes. And we know that because any number divisible by 2 when the last digit is even. So let's see, 100 over 3, is that an integer? No. That equals roughly 33.333 repeating. 100 over 4, we can just keep going for the heck of it. That is an integer, that's 25, and 100 over 5, that is also an integer. So now, from working through it, we see that C is the correct answer. The alternative way to do this problem, if you can't quite think about it this way, is you could just fill in these numbers from the beginning. So what I could have done is just started with the number 1, and I would have had 100 plus 1 over 1. This equals 101 over 1, which is an integer. And I could have just plugged them in, and you might find that easier. If you're really good with your divisibility rules, that's probably just as easy. I think my mind just thinks, I don't know, maybe a little bit more complicated, you could say. So anyways, I hope that helps. I will be back soon with some additional integer problems. Thanks for watching.